Hey folks, Jim here with Science Talk. Want to share with you an abstract from a recently published paper published at the end of October of 2022 in Geophysical Research Letters. The title is Abrupt Northern Baffin Bay Autumn Warming and Sea Ice Loss Since the Turn of the 21st Century. And Thomas Ballinger, Moore, Quintana, Myers, Imrit, Topol, and Meyer are the authors. A lot of these names are familiar to me, as I've read a lot of their papers. So let's look at the abstract, look at key points, and then a plain language summary and what it all means. A delay in autumn sea ice formation is an important consequence of Arctic amplification. Baffin Bay is one such region impacted by delayed ice formation, though spatiotemporal analyses to date have not detailed the evolution and drivers of such autumn ice changes. In this study, we document abrupt Baffin Bay sea ice cover changes in the key transition month of October from 1950 to 2021. The ice cover mean and variance dramatically changed from 2001 onward, with a transition to largely ice-free conditions in the northeast and thinner ice in the northwest. Largely ice-free conditions in the northeast, thinner ice in the northwest. Ocean model experiments attribute these changes to warming of the Atlantic origin water flowing into northeastern Baffin Bay from the south. Transport and upwelling of this above freezing Atlantic origin water has stunted ice formation in this area, while the basin's cyclonic surface current has contributed to reduced cooling and ice formation in the northwestern portion of Baffin Bay. Reduced cooling, in the way of saying of increased warming. So the basin's cyclonic surface current. Cyclonic flow is counterclockwise in the northern hemisphere. And that has contributed to reduced cooling, increased warming, and ice formation. So we got reduced cooling, reduced ice formation in the northwestern portion. So we're losing the ice in the northeast part of the bay, and in the northwest, the ice is getting thinner. So we're losing the multi-year ice, basically. So what are the key points? A reduction in October northern Baffin Bay ice cover is observed around 2001 and is characterized by a westward retreat of the ice edge. That's a really excellent way to summarize, mostly ice-free in the northeast and the thinner ice in the northwest portion of the bay. It's retreating. The spatiotemporal shift in the ice cover coincided with observed warming of surface air and ocean temperatures to inhibit ice growth. An ocean model suggests the ice loss is spatially coherent with Atlantic water mass warming on the eastern flank of northern Baffin Bay. Okay. What's the plain language summary? Delayed sea ice formation during autumn is a signature of Arctic warming, which affects regional Arctic climates and ecosystems. Baffin Bay is one such area of later ice growth through time, which we investigate further with observations in an ocean model. Our analyses show a remarkable change in Baffin Bay's ice cover since 2001. In the last 2 decades, 01 to 21, northeastern Baffin Bay has transitioned from partially ice covered to primarily open water state, with ice formation now occurring about 2 weeks later. Observations suggest much warmer surface temperatures are responsible for this change in the ocean environment. An ocean modeling experiment confirms this recent ice loss pattern and attributes to the transport of warm Atlantic water across northern Baffin Bay. Okay, let me first, orientate folks here, so kind of get an idea of the area being considered. So here is Baffin Island, indicated here in white. Don't leave that there. And here is Baffin Bay itself. So here's Greenland. And as you can see, through the Davis Strait, it opens up into the Labrador Sea. And here, of course, is Hudson Bay. So when they're talking about from the northeastern to the northwestern, they're talking from basically here to over here. So basically up into these other parts of the archipelago. Now, there's another thing of interest to note here. In this region are the last remaining remnants of old sea ice, of the multi-year ice that's like 6, 7, 8 or more years of age. These are the last remnants of it. And what are they saying? They're finding it's disappearing. So we're almost very close to losing all of the multi-year ice. Now, they're saying of the influx of Atlantic origin water. Well, we know the Atlantic water comes in over here primarily through the Fram, and it tends to go up around onto the on the Eurasian side before circling and around, coming over to the North American side. So that indicates that there is some warm water making its way in. It's not likely to come in this direction because the currents are out here and it moves this way. Plus you have the very strong Labrador current that's very cold, and that's going to displace any other waters coming in. So it's telling me that the warm Atlantic water is making its way around to this side and infiltrating. Now, they talked about a cyclonic flow. That means it would be in this direction, counterclockwise. So we can see that it would, if the warm water comes in through these various channels, whatever, this looks like a good candidate right here. You can see how it would get entrained and then goes this way, so the warmer water comes here first, removes most of the ice, continues this way to thin the ice. So this is the region that's being considered in this abstract. Now, the other thing they talk about is, October. The sea ice is really not freezing up in October as it has in the past. In fact, usually in September things start freezing up. I know you're going to say, but wait a second. September is the oceanic summer. So how can you start forming sea ice? Because the Arctic Ocean wasn't getting really warmed up that much. It took a while for all this accumulated ocean heat to significantly have warmer water moving into the Arctic Ocean. Before, the Atlantic waters would be warm, but before it started accumulating all this heat and warming up, by the time it got to the northern latitudes, I'm talking about pre-2000, pre-2001, by the time it got there, it was cold enough that it would not impart any heat flux, heat energy to impact what happens in ice formation. That has all been changing rapidly in the last 2 decades. Now the water is sufficiently warm enough that it is preventing the ice from forming. It keeps the ice, ice-free longer. It delays the, as I just said, delays the ice formation. It melts the ice sooner. The there's more open water for a longer period of the year. It's gone from some 5.5 months to now 7 months of the year that this season has expanded. So that means in October, instead of having ice, you've got open water. And that then translates to, well, you have the heat flux to the atmosphere, and we get things such as here in Alaska, where October is now the month of the year where we see the greatest disparity between average temperatures and current temperatures. In other words, the warming is felt the greatest in October. The greatest temperature differential between average and current conditions. I mean, June, July, yeah, it's warm. That's the warm time of the year. So the difference now to average is not as great as in October. And keep in mind, October, we're on now the downside of the autumnal equinox. So there is less daylight than darkness. So, you start getting under 12 hours of sunshine, and you start getting down to 11, 10, 9 hours or less. So you have all that heat energy fluxing, and that's impacting the ice. But what is surprising to me is that we're now seeing some of the first evidence of this impact onto the ice on the North American side. What's happening in the Eurasian side, I've discussed with you plenty before. And I've done quite a few videos of that, and you can be sure that more will be coming down the pipe. The fact that this is happening now in Baffin Bay, where the last remnants of the really multi-year, the really old sea ice is at risk, is extremely telling and alarming. So I kind of wanted to share that with you. We're gathering more and more evidence of what warming oceanic water flowing into the Arctic Ocean is doing to the ice, be it from the Atlantic, be it from the Pacific side. The Arctic is transitioning, and what happens in the Arctic does not stay there. Warming 3 to 4 times in the rest of the planet, that will spill over. Thank you for your time.